Cold weather can create unique challenges for asphalt paving, from temperature sensitivity to compaction and ultimately durability concerns. Today, our presenter, Tom Clayton, Tom's going to share some practical guidance on planning, placement, and achieving quality results in paving in cold weather conditions. I call Tom a friend. I've known Tom for 35 years, and Tom is with the Colorado Asphalt Pavement Association, and Tom brings more than 45 years of experience in asphalt paving and construction. He's worked extensively with contractors, agencies, and industry partners to improve pavement performance and construction practices. Known for his deep expertise and straightforward teaching style, Tom has become a trusted resource for paving professionals across the country. So, with that, I'm going to give it back over to you, Tom, and share with us some best practices about when is it too cold to pave.
Thank you, Mike. I appreciate the opportunity to present to you all today. As you said, we're here in Colorado and we had our first freeze warning in the Denver metro area overnight. And you look out my window, I'm looking out the window here to my left, and it's a beautiful, bright, sunny day. So you said that we had snow up in the mountains. Drove those mountains just last Friday. Headed up over Berthoud Pass into the Winter Park area and then beyond. And while we topped over the pass, it was snowing. So yeah, we're at that point, Mike, where we're going to see snow and we're going to see a lot of it before we get too far. Like I said, I appreciate the opportunity to present to all of you today. And as Mike said, I'm with the Colorado Asphalt Pavement Association, and I'm here to be a resource for you. So there's a little caricature of myself that I got done a couple of years ago when I was at Con Expo. And my statement here is, why am I here? And it's because I love to give presentations. As Mike said, I've been in this business since 1979, working on one side or the other. I worked extensively for a geotechnical engineering consultant as a field technician inspector, managed a field operation, and assigning the technicians and troubleshooting from the backside on the geotech side. And then I've been here at CAPA as the director of training and member services for 24 years, nearly 24 years. So I've got a lot of background. So you can see the picture there. I posted that picture. That was a project that was done here in Colorado. Oh, I want to say it's 3 or 4 years ago now. Really lost track of time, but went out and took that picture. I thought it was a very interesting picture. You see the contractor had the paver out and they were melting the ice off of the road so that they could pave. They weren't running any material through the paver at that point. They were simply wanted to put a top lift down. So they heated the paver up and were running down the road to get the ice to melt off the road so that they could put the top lift on it. Pretty interesting thing. So question that we ask as we move through this today is, when is it too cold to pave? You're going to be a lot of different things that I'm going to talk about. And I know I'm talking to people from around the country and you're going to have a lot of different things, and you're going to hear me reference a lot of things about CDOT, or the Colorado Department of Transportation. But I believe that most specs across the country and the people that I have talked to and places that I've been and spoke across the country have the same type of temperature table that is in the CDOT specification. And CDOT, it's table 401-3. And I believe that there's a lot of places around the country that have that same type of thing. And it talks about where you have to have 40 and rising or 50 and rising and whatever that is, whether you're talking about the ambient temperature or the ground temperatures. Here in Colorado, we've made a push, or I've made a push, to eliminate the ambient temperature as a hard spec, using ambient temperature simply as a guideline to help the agency, the owners, to make some ideas of when they want to be paving. But the ground temperature is what should be the driver, because if you're looking in here, one of the statements that I talk about is that we want to make sure we're placing the material on properly prepared unfrozen surfaces which are free of water, snow, and ice. Well, those things are definite that we have to have. We know that when we're placing on materials that are not within what we expect, having the proper temperature of the ground, proper temperature of the materials, that we could end up with problems that will not show up the first year or the second year, but will show up at some point down the line. So we want to make sure that we're doing things properly so that we can get the material down, we can get it compacted, and it will give us that long-lasting pavement that will get years and years and years of life out of. So, as Mike said, the temperature is starting to drop. We're seeing people are starting to get into a little bit of a panic mode. We've had, like I said, we had in the Denver metro area, we had our first freeze warning overnight. It didn't get real cold. It got down to, I think, 30. So, I mean, it wasn't a real big deal, but our ground in the metro area is still very warm. It's probably in the 55 to 60 degree range because we've had a very mild fall. In other parts of the country, I know I was speaking to our newest employee who is coming to us from Minnesota. He's told me about some really cold temperatures that they have in mid-state Minnesota and up north toward the Canadian border. And so they're already panicking up there. So those are things that we want to make sure that we're looking at. Cold weather, we have to prepare for it. We know it's coming in our climates where we do get the colder weather in the northern half of the United States. We know we have to prepare for it and we have to do the right things. So we're going to talk about some of these things and we're going to push through them. And as I go along, if you have questions, again, like Mike said, pop them into the chat window and we can chat about them as we go along or after. So what are the considerations for paving in cold temperatures? Well, you can see I've got 3 bullet pointed items there: the ambient and surface temperatures, and then the temperature of the materials being produced. So it's important that we look at all of those. So one of the things I like to do when I'm talking to people about this is I want people to rank those 3 things in importance of the items as we're going along. So as all of you are sitting here looking at this, in your mind or write down or whatever, what is the most important? The ambient, surface, or the material being produced? What are the most important temperatures? What's the number 2 and what's the number 3? So in my mind, the number 1 is the surface temperature. If we have a good surface temperature, like I've talked about here in the Denver area and the Metro Front Range, where we haven't had really cold temperatures yet, even though we had a very cold overnight and our ambient temperature today is in the mid 40s to upper 40s, there's no reason that a contractor shouldn't be able to go out and put down asphalt and do it properly and not have problems. So that surface temperature, if the surface is too low, it starts drawing the heat out of the mat, and the mat compacts. We all know the mat compacts from the bottom up, not from the top down. So it pulls the heat out of the mat, which sets the binder very quickly. So the bottom part of the mat, depending on how cold it is, will affect how much of that binder actually sets so that it will not compact. And then we have to compensate with the rest of the thickness that we're putting down, let's say a 2-inch thick mat, and we cool anywhere from 1/4 to 1/2 inch of the bottom. So we've got only 3/4 of what we put down that we now have to over densify to get the density in the mat that will pass the compaction specifications. So when we do that, we overtax the top part of it or potentially crack or fracture the top part of the mat, while the bottom part of the mat is going to stay very soft. When it warms back up in the summertime and then goes through another freeze-thaw cycle through the next winter, we're going to see deterioration happen quicker than we would if we had not had that occur. So the second thing is the material being produced. A lot of people would say, oh, well, if the surface temperature is number 1, the ambient temperature should be number 2. In my opinion, no, it is not. The material being produced, we want to make sure we're getting material out of the plant with competent and proper temperatures. And that doesn't necessarily mean that we're going to turn the plant up. And there'll be a question coming up, and we'll talk about that. But do we want to get the material out of the plant hotter? And my first response to that is no, never. We don't want to do that, because if we do that, we are pre-aging the material coming out of the plant, being put into the trucks, hauled to the site, and then run through the paver. By turning those temperatures up, we burn the light ends out of the binder, which then makes the binder brittle. So in a cold weather situation, we turn the temperature up, then we got another problem that we're going to create, then go through the freeze thaw cycles year after year, and we're going to deteriorate the life cycle of the material. So we have to really be thinking about it. The third one is the ambient temperature. And as I talked about before, ambient temperature in the specifications is usually a hard and fast number, 40 and rising, 50 and rising, 60 and rising. My question to everybody and my question to all that I talk to is, okay, we're gonna stick to that temperature spec where it's 40 and rising for whatever a top lift, or 50 and rising for a top lift, 40 and rising for a lower lift, whatever it happens to be. So that means that we're going to get to 40 degrees and we're going to get the go ahead and start placing material. But then it gets up to 48 and that's the top for the day, and it starts dropping. That means at that point, by reading the spec, if we're going to live by the law of the spec or the rule of the spec, is it says and rising. So when it gets to 48 and then it drops to 47, that means it's time to stop paving. We know that doesn't happen, and we know that is not what is intended. What is the intent in the spec? The intent in the spec is that they will start paving and then they'll keep going once it hits that minimum temperature. With ambient temperatures, I was involved in a project several years ago where the inspector on the project was holding a contractor because it was 38 degrees ambient temperature. They had 10 belly dumps full of material sitting on the site ready to go, and the inspector held them for 2 degrees. They sat there for several hours waiting for that temperature to come up, and that material sat in those trucks just sitting there, cooling and cooling and cooling. In my mind, I told the contractor at that point, you should have just put it down and just got your thermometer out and told, look, my thermometer says it's 40 to 42 degrees, whatever it is, we're going, get out of my way, and then prove to them through the process of placement and compaction that you were able to do what you need to do, is like, even though, and you had the plenty of ground temperature to do it. So those are things that we got to be looking at on a regular basis. So we know that frozen subgrade base, even doing a top lift on a cold or very cold frozen surface, was going to be a problem. And I talked about how it will rapidly pull the heat out of the mat. And it's not a slow process. It'll rapidly pull it out. The heat transfer will go from the material being placed into the subgrade base or the existing asphalt layer, and it will draw it out very quickly. And that will then cool the mat for a compaction process. For the compaction purposes, it will then deteriorate the life of the mat and what we do through those additional years of freeze thaw. We have to be very careful of how we look at that and what we're going to do. The thing about a frozen subgrade or a frozen base course is you'll drive trucks over it. You can drive heavy pieces of equipment over it, and it will look very stable. It'll look very solid, but it may have a high moisture content. And when that hot asphalt, 300 degree, 275 degree asphalt gets on it, it will thaw that subgrade very quickly and could turn what would appear to be a very stable base into a very swampy base very quickly. That heat being drawn out and thawing that down out. We think about an ice cube. An ice cube, when it comes out of the freezer, is very hard, very stiff. But if we leave it sitting out, it becomes a puddle. If we have subgrade that has a high moisture content, or it may have snowed on it or rained on it and then froze, that it looks very good. We have to be very careful about what that is. We want to make sure that we don't have that. How do we check for frost in subgrade? Well, it's not as simple as taking a thermometer, and most of us are using non-contact type thermometers, as infrared type thermometer, taking a shot at the surface and going, oh, it's frozen. That's great. It's going to give you information, but that's not the information you want. You want to get somebody out there that's going to dig a hole down, try and figure out how deep that frost has penetrated. If there's frost and it's an eighth of an inch, a half an inch, even probably up to 3/4 of an inch of frost, that typically isn't going to be a real detriment to the placement of the asphalt. If you get much deeper than that, an inch or more, you were starting to get into the territory of wait a minute, we probably ought to rethink what we're doing here and get that frost to come out of the ground. A little bit of frost on the surface. That's why it is important that the technician on site gets a shovel out and digs down to try and determine the depth of the frost. Not just is it there. It's very simple to prove that it's there. But now we want to see, okay, it's there, but how much is there? If it's a minor amount, like this morning here in the Denver metro area with our freeze overnight, we probably had a little bit of frost in the ground, but it had been so minor that there was no reason why a contractor couldn't have gotten out this morning and started paving as soon as the sun came up, because we had such a minimal amount of frost overnight. So it's important that we look at that. The other things that are going to be drivers in that are what is the current ambient temperature and the wind speed. Wind and cold air will help to create additional frost. The other thing that we have to be concerned about is they don't pave today. We had a frost overnight. We have frozen subgrade. We get another cold overnight. So every night they're going to get a little bit. The sun comes out. You get a little bit of melting on the surface. Then the cold comes in again overnight, depending on how cold it gets. 20 degrees, 25 degrees, 30 degrees, whatever it is, it's going to drive the frost deeper. So every night we're going to drive the frost deeper and deeper and deeper as long as we keep having the overnight freezes. It'll start with a little bit and it'll get a little bit more and a little bit more and a little bit more and a little bit more every night, as long as we're having those continual freeze thaw cycles. And here in our area, we could have 10 freeze thaw cycles in a day. So those are things that you have to be thinking about. Sun comes out, it may be a very cold day. We have days here in Colorado where it will be an ambient temperature day of 30 or 35 degrees. It will feel very warm. We'll have things melting because of our elevation and the way the radiation from the sun will melt things even on a very cold day. 20-degree day, we can see melting going on. So we get the freeze thaw cycles that are going on. So it's very important that in those months that we are not just making assumptions, that we have to make very true determinations and that we are getting the material down and we know exactly what we're putting it on. I talked about this just a second ago, paving over a existing paved surface. The problem with paving over an existing paved surface is that you have to tack. We put the tack down. It's somewhere between 160 and 175 degrees coming out of the back of the tack wagon. We spray that down. We put it down on a cold surface. It is going to be a heck for it to dehydrate or to break. The process of breaking tack, what we all talk about breaking tack, is a dehydration process. The water coming out of it. It's an emulsified asphalt that has been then thinned or cut with water so that it can be sprayed out of the tack wagon or the tack truck. So we want to make sure that we get that tack to break. Not only does it break, but we want to make sure that it will set as well. The third step. So the first step is to spray it, place it. The second step is for it to break. The third step is for it to set. And we can all work on that or get an image of that difference between breaking and setting. Those of us that have been on projects, that have looked at projects, the breaking, we say, okay, it's good to go ahead and pave. We start backing trucks and we start backing the paver in, and they're picking the tack up because the tack hasn't completely set. So we want to make sure that the tack will set on that cold layer, that cold asphalt or concrete layer that you're going to be paving over. You want to make sure that will also set, not just break, but set. So we want to make sure that we have that so we can get that good bond of materials, the new layer to the old layer. How do we get the material from the plant to the paver and we don't lose tons of heat out of the material? Well, we know that we have to tarp our loads because it's mandatory by laws in most states that we tarp the loads so that product and particles don't fly out of the back of the truck and hit people, windshields and vehicles that are falling too closely to the delivery trucks. So we have looked at it, and we know that the research has showed us that the tarping has very little effect on maintaining the temperature in a truck. Tarps are not, in most cases, are not insulated. The bed of the truck is not insulated. Therefore, we have to do things to hope and help get that material from the plant to the paver and hold and maintain as much heat as possible. So putting that tarp on it, when they start driving, what it's going to do is it's going to rapidly cool the top layer of that asphalt. So it will seal it up. That's a problem because now we got temperature segregation going in our material that we have to be thinking about. So when it cools that top layer, it seals the voids or somewhat seals the voids up, the loose voids in the material. So then the rest of the material is sitting in there and it's acting. So now it acts like a convection type oven or an oven. We get an oven effect. The walls of the side walls of the truck have cooled the outer edges. The top now is cooled. The bottom is cooled. So the stuff internally is going to stay warmer and it's going to hold its own heat. Just like if it were being put in an oven, it will hold its own heat. Yeah, the outer edges are cold. And we have to think about that when we unload that truck so that we don't get the thermal segregation running back through the paver. That becomes another issue. So the way we do that is we have to unload the trucks properly, and we'll talk a little bit about that as I move along here. So once we get out to the site, we want to make sure that we're not getting that temperature segregation in our material. So it's important that that cold crust of material be blended back into the hotter material so we get a consistent temperature of the material that's in that haul truck, whether it be a tandem, a super tandem, a trailer, a dump trailer, a flowboy type conveyor unloader, or a belly dump. We want to make sure that we reblend that material so that we don't have a hot layer and a cold layer, or a hot zone and a cold zone running through that. And you can see in the illustration here where the arrows are, those were cold spots in the mat, and that was because of the way they were unloading the trucks. So it's important that the trucks be unloaded properly. The best way to unload the trucks is to break the load prior to releasing the load. Okay. So what I mean by that is if it's a dump type truck, whether it's a tandem, a super tandem, or a dump trailer, they raise the bed of the truck up without releasing the tailgate. That breaks that load loose. And then it starts that movement again to start regenerating or remixing the material back together. So then they lower the bed of the truck back down. The truck then is picked up by the paver. The paver runs into the truck, picks the truck up. The bed comes back up, but during this whole time, the tailgate is still locked. So the bed is up, the material slid against the tailgate of the truck. Then they get the signal to release the material. Then it slides out of the back of the truck into the hopper of the paver in a gob. We want to move material in gobs. When we don't do that, and we probably, many of you that are on this today have seen it, where they pop the tailgate, they start raising the bed, and you get a slug of coarse material that has just been through the transport tumbled back near the tailgate. We need to encapsulate all that material and try and break that crust loose so that as it starts moving, we can get it through there. Then we get it to get remixed in the paver through the drag slats back to the augers. It's being remixed so you don't end up with these areas that you see here in the mat where you have that segregated material. This was all segregated material that came through the trucks, and it's picked up. It's very obvious to pick up in a paving situation. So we want to make sure that we don't have that. These areas are not going to compact the same as the areas in between here to here, and from this arrow to that arrow, and that arrow to the next mark you see there, and the next mark you see there, the next mark you see down there. They're not going to compact the same. You're going to have differential compaction in there. You're going to have to apply different amount of energy. And the problem is that nobody or most people don't even realize that. So the roller operators don't change what they're doing. So it's important that They are not creating their own problems. So here, a definition is what we're looking at. Temperature segregation is the presence of masses of mix in the mat with temperatures differential that prevent uniform placement and or compaction. It's what I was showing you in that last picture. So how do we eliminate that? And that's what I talked about. The first thing is if they're in dump paving, or even if they're using a conveyor type paver, a Flowboy, Red River, whatever you want to call it, the same thing should occur with those type of vehicles. Keep the tailgate latched, turn on the belt, get the material moving back to the back when they're picked up by the paver. Then they release the gate and the material comes out in a gob back into the paver. We want to try and remix as much as we can. The other way we can do that, and then with the belly dump, we're going to get the remixing because the material is going to come out of the belly of the beast, the belly of the truck, picked up by some type of a pickup device, whether it be a pickup device hooked to the paver or a pickup device on a transfer vehicles, such as the shuttle buggy or the Weiler transfer machine. Then you have a remix there, so we can keep that temperature segregation to as minimal as possible. So we want to make sure we do that. So there's another way we can work and make sure that our materials are going down, and we don't have to really be highly concerned about the temperatures, and that's about using additives. And the additives we can use are chemical additives, organic additives, or water molecules of water, and they all will work in a similar manner. Some people like the organics better than the chemicals. Some like the water spray better than the organics or the chemicals. It's a preference. There is not a hard and fast rule out there of what is better or what it is, but we call those here in Colorado, most places across the country call WMA or warm mix asphalt. We have backed away from that. We call it a workability mix additive. Because in my opinion, and through what I have been pushing for the last 25 years, is 275 degrees, what we hear people saying, oh, we're going to turn the plant down to 275, put a WMA in it. Well, 275 to me is still pretty warm. I don't want to grab anything that's 275 degrees. So it's still pretty hot. But what those additives do, whether they be the chemical, organic, or the water additives, what they do at that point is they make the material much more workable at lower temperatures. So we can turn the temperature down and we can make the material still workable or more workable even at lower temperatures. So lots of manufacturers of these products. I would tell you that one is better than the other, but I can't do that because they're all very good materials and they're all out there to help. So WMA in 2025, we know that we're using it, and I can go around the horn here, placement in colder temperatures. We hear a lot that this time of year where our producers are saying, oh, we're going to put an additive in. But I know there are producers in Colorado that are putting WMA in their mixes all the time because they get the advantage of it. Even in the warmer temperatures, they're getting an advantage that they can get it compacted faster. We know that it'll extend the workability. I have been on projects where they have actually worked material down to 110 to 120 degrees without causing any damage to the mat during the compaction process. The best explanation that I've been given by any of the really smart people that are in the WMA world is that the WMA, as long as it's being worked, will remain active. But if you get off of it for any period of time, and the colder it is, the faster that period of time is. In the summer months, it's not as fast. But as soon as you do that, the product becomes basically inert. And it just kind of is there anymore. It's not workable. It's not usable. We're using production in lower temperatures. A cold day, a 40-degree day or a 50-degree day, putting the WMA in there, it's just going to help with our production. I'm going to jump across here to the other side, and it's a compaction aid. We know through years and years and years, I've been dealing with WMA since 2003, and I know that over the years, the one thing that we do know is that it is a compaction aid, and contractors can and will get compaction faster and with less effort. In our hauling, again, talking back to what I talked about just a couple of minutes ago, in the hauling process where we know we're going to get the crusting, we know we're going to get the temperature segregation in the material. We're going to see where during the hauling process now, we're not going to see as dramatic of temperature swings that we do if we don't have the WA in. And then the last one is the handwork. If we're going to do, if we know, and we know that on most projects, you've got even minimal to maximum amount of handwork. Parking lots, obviously a lot more handwork than if you're paving on an interstate highway. But the handwork becomes better. It becomes easier for the laborers to do. So those are things that we want to look at. So these are all the uses for WMA. And you can see, and there are probably more that I haven't put on here, but these are the 6 spokes that I know of that are very beneficial to WMA. There are a couple of different programs out there that can help with the placement of the asphalt to give, basically it's not a hard and fast rule, but it's to give a kind of a guideline. This one is called Pave Cool, and you can see the link for it. It's dot.state.mn, which is Minnesota. And you can go on and download the app, and you put in the data, you put in your data in there, the air temperature, the wind speed, you know, what is it? Clear and dry, cold and dry, whatever it happens to be. You put your latitude and longitude in there, and it will give you a curve. And this curve that you see here is the time to compact. So you started out with a 260, 270 degree material. And you got your time to compact up here to 80 minutes or 60 minutes or 40 minutes. But this is the zone where you got to be. You're down to 180 degrees. You got 40 minutes to get to 180 degrees. So it's just a chart. It's a graph that will give you some comfort. There's another one out there, and it's called Multicool. Multicool is an app that you can put on your cell phone. The app is available from the Google Play Store. Does basically the same thing. It is virtually the same as Pave Cool. But you can see that it will give you estimate that if you're paving 1 inch, 2 inches, or 4.5 inches, what your mixed temperature is, what your base temperature is, and then how long you have to get the material. All 3 phases, breakdown, intermediate, and the finish roller to get it done. So those are things that we got to be looking at. Those are tools that we have that are available to us that we can look at, that we can get better results by paying a little bit of attention to. I put this in here as simple illustration to make it very easy for people to understand. I use this in several of the other classes that I teach or other events, sessions that I do. But if we have a mixed temperature of 300 degrees Fahrenheit and a base temperature, nobody that I know of has 90-degree base temperatures, but unless you're maybe in Phoenix. But then we're not worried about cold temperature paving. But let's say 60 degrees, which is kind of a common temperature for pavements around Colorado, eastern Colorado, and western Colorado, not in the mountains. But we get ground temperatures, a base temperature of 60 degrees. So we're going to put a 2-inch mat down. So we just run up here to 60 degrees. Then we run across here, and it's about 21 or 22 minutes to get the entire 3 phases of compaction applied to a mat. We're putting down at 3 inches or at 2 inches. If we go to 3 inches, again, we'd run up here. We'd get to that 60-degree point, which would way up here. And you can see at 3 inches, we're going to have 35, 40 minutes. But we change our temperature. So now we have our base temperature here at 60 degrees with our mixed temperature of only 225, where we were at 300. Now we're at 225. With that same 2-inch mat, we come up here and hit that 60 degree and interpolate it across. We got 8 or 9 minutes to get all 3 phases of the compaction done. We go to a 3-inch mat, again, hit that 60, then we come across and we're at about 16 or 17 minutes. So you can see it basically doubles the time for that extra inch, but we don't get to say, well, today we're going to put down 3 and tomorrow we're going to put down. The job is what the job is. If it's a 2-inch mat, it's 2-inch mat. But you can see if we're on a 1-inch mat at 300-degree mixed temperature out going down and on a 60 degrees, we have about 7 minutes. If it's a 2-inch mat, we aren't even going to be able to, it's going to be a real fight to even get there. 2-inch mat. We're going to be up there. So those are things that we've got to look at. We got to make sure that we're paying attention to our temperatures, the mixed temperature and the ground temperature. Those are the two things that we got to look at. So when we're talking about this is out of the temperature chart that we looked at, where you have 1.5 inch top layer, layers below the top layer. These are temperatures, 60, 50, 45. The note that I put in here is talking about the temperatures. We take ambient temperatures in the shade instead of in the sun. The sun will give us reflection that we don't really have. We all know if we go stand out in the sun, it's going to feel a lot hotter than if we're sitting in the shade. The direct heat from the sun is way different. So we want to make sure that we're taking our temperatures in the appropriate place. Again, ambient temperature should be a guide, not a hard and fast rule. This is what should be should be looking at for ground temperatures or surface temperatures. This is where we should be living. That's the world that we should be living in. So we know that mixed temperatures are influential factors on the time available to compact. That chart that I just showed you 2 slides earlier is a great indication of that. So the obvious solution is, and I talked about this just a minute ago, was, we'll just turn the heat up. Well, how much can the temperature go up and how much does it cost? And I don't mean in dollars, but there is a dollar value to it. How much does it cost to turn the temperature up? But what does it cost in damage to the mat, damage to the material going down, and the life of the material? So if we turn the temperature up just to get the compaction, get it down and get the compaction today, but we lose 5 years of life, was that worth it? If we lose 7 to 10 years of life, was that worth it? So those are things that we have to look at. So we have to be very careful about what we're doing and what causes we're doing by simply turning the temperature up. The other things that we can do instead of that. The NAPA QIP 118, which is a cold weather compaction document, downloadable off of NAPA's website. They say that it's probably okay to turn the temperature up 18 degrees above the recommended temperature. That comes from data that was gleaned out of the Asphalt Institute, where they did a bunch of research that said, okay, well, we could think that you can make this oil hotter without really losing a lot of the light ends in it or causing damage to the binder. We have since found out that isn't necessarily true. A lot of that we thought by doing that, by raising the temperatures, we weren't causing that. We're seeing more and more now where if you do raise those temperatures with our blended binders, especially when you get into some of the highly blended binders, we have created a monster that we don't want to do. I wouldn't typically recommend turning the temperature up at all. If they're saying 290 degrees is the proper temperature for a particular binder, 64 minus 22 binder, the maximum heating temperature is 290. That should be the maximum heating temperature. We should do other things to help us on the backside. Add the WMA in. It's going to cost less dollars to put the WMA in than by losing life in the mix for losing years and years and years of life. So raising the temperature is going to potentially increase the premature aging. So we want to make sure that we're doing the right thing to give us the best chance for success, long-term success. So we have to look at, what are the goals of compaction? The goal of compaction is to get the material compacted with little or no damage at the normal compaction temperatures, generally 175 to 275, about 100-degree swing from the time it goes down to the time we should be off of it. The finish roller should be done around that 175. With lower temperatures, things are going to vary a little bit. If you got a WMA in there, that 175 might be 155, might be 140. Who knows? But we have to look at and make sure that we are not doing things that are going to deteriorate the life of the pavement simply because it's cold. If it's too cold, why are we paving? So normal production temperatures, compaction is again finished between 160 and 180. If the WMA is added, that temperature can be adjusted. You can see my rule of thumb right here that I've put in would be that the inspectors and the testing technicians be keenly aware of the condition of the mat while the compactive effort is being applied. The introduction of fine cracking, or what some people call fissure cracks, would be an indication that that binder is setting up. If we start seeing those little cracks, so the roller goes one direction and you see little fine cracks all across the mat under the footprint of the roller, that's an indication that the binder has started to reach its set point, where it started to cool past its go from liquid to solid. If they come back the other direction and those cracks seal back up, that's generally not going to be a problem. But if they come back the other direction and those cracks do not seal back up, that means that we have probably reached the temperature at which they should be off of the mat, not to create additional problems through the compaction process. The things that have to be very aware of and make sure that we are not, through our compaction process, causing damage that is going to lessen the life cycle of the material. Question gets asked all the time: should we use more equipment? The simple answer to that is sure. But the reality of that is most paving spreads, you don't just get to, oh, we got extra equipment today. That's just not the way it works. So if we have more rollers or higher capacity rollers, that's simply going to help. One of the keys here is when the material's coming out of the back of the paver, the breakdown roller needs to be operating as close to the paver as possible to seal the mat, close those open and interconnected voids, to hold the heat, as much heat as possible. If they wait too long, they allow for the heat to escape from the mat through the open interconnected voids, then we're going to lose compaction time and we're going to have more of a fight on the back end, especially when we're getting down to the finish roller. And I just talked about the fine cracking that would go along through the finish rolling process. If we have that going on, it's just a matter of changing the process, keeping the roller closer to the paver, sealing that mat up, which means that the intermediate roller is going to have to be kept closer and the finish roller is going to have to be kept closer so we can work it while we still have the temperature and we're not letting the temperature run out of the mat or being driven out of the mat. We want to make sure that we keep the temperature in the mat as long as possible. So some specific actions that we might look at to make sure that we have a quality and long-lasting mat. We can go around the circle here. We want, what to do. Well, we increase the temperature. We increase the temperature, but we can only do that a certain amount. And again, what do we do? Can we increase the layer thickness? Like I said a minute ago, the layer thickness is what the layer thickness is. I mean, if it's specified as a 2-inch mat, then it's a 2-inch mat. They don't generally have the ability to go, well, we are not going to do 3 now. Well, that's just not the reality. Minimize the time or length of the haul. The only thing that we can do with that is that we can space the trucks so that they are not sitting on site. The plant is where the plant is. The haul distance is what the haul distance is. That is a given. We cannot adjust that typically. We can't just pick up the plant and move it. We can't pick up the project and move it closer to the plant. Those two things don't happen. So what we have to do is we have to change what we're doing. We don't want to have 5 trucks sitting in front of the paver. We want to have one at the paver, one in front of that, and everybody else in motion. We get 5 trucks in front of the paver. That's where we start causing problems. We can simply put in a compaction aid, put in a WMA to help us with compaction. Using additional or higher capacity rollers. We go from a 10-ton to a 12-ton, a 5-ton to a 10-ton. We get that done. We keep this, what I just talked about, keeping the rollers as close to the paver as possible. And then these two that go together, minimizing the haul, but really reducing the wait time while they're ready to unload. Those are the things that we can do to help us create a quality and long-lasting asphalt paving material. I didn't explain that. A lot of people around the world are still calling. We have hot mix asphalt, hot mix asphalt, hot mix asphalt. We have again renamed or re-acronymed asphalt paving material because we don't know whether it's a material that's an SMA, an open graded friction course, a WMA, has a WMA in it, what it is, a porous asphalt. We just simply call anything that's hot, black, and sticky APM or asphalt paving material so that this applies to everything that we're doing. So is it worth the extra cost to place APM in cold weather? This statement right here is probably the real driver. Ultimately, only the person paying the bill can answer that question. There will be a lot of times when, and I'll bring this up in probably the next slide or so, a lot of times when they're getting pressured to get an asphalt parking lot in this time of year so that they can work through the winter, or that because they know they're going to close a building, or they're going to have something that needs to be opened back up in December. So they have to get it done, have to get it done. Well, the answer to that is, how bad does the owner want it? And we'll talk about that in just a minute. But then if the decision is made to place it in the cooler temperatures, it's going to cost a lot less to do it the right way, right, the first time, than to have to go back and remove and replace. I've talked about that several times during this hour, that if we're going to do it, we want to make sure that we are going to meet or exceed what the anticipated life cycle was for that pavement. If it's not done right the first time and we have to do remove or replace, that means that we probably have not met our initial life cycle analysis or life cycle prediction. So going back to, ultimately, it's the first person or the person paying the bill that's going to make that decision. Well, there are a lot of these are two paving contractors here in Colorado, Brandon Sand and Gravel, one of our larger paving contractors. And this is their typical release of responsibility. This one is from Kiewit, Kiewit Western or Kiewit Infrastructure Group here in Colorado. This is older, but this is their total or unconditional release. You want me to pave, and we're telling you that the conditions aren't right. Here, Mr. Contractor, Mr. Owner, please fill this out and sign it. You sign it, we'll sign it, but this takes our liability away. That if it doesn't hold up, if it doesn't meet the life cycle cost, we, Brandon Sand and Gravel, we Kiewit, whoever the paving contractor happens to be, we're not responsible for any maintenance and or repair based on that. This is our total and complete release of liability for any damage that is caused because you want us to do something when we are the experts. We are the paving experts, and we're telling you this is not a good idea. This is a bad idea. We should wait, or we should do something different. One of the things I didn't talk about in here today was that there is other equipment out there today. We have ground heaters, we have heated blankets, we have all kinds of things. Heated blankets and ground heaters are great in small paving operations. If you've got a small parking lot or some small area that needs to be paved, using ground heaters or heated blankets or insulated blankets in a large area becomes a real cost generator. I have been on projects where they get a subgrade prep and they'll do a whole street, residential street, maybe 500 to 1,000 feet long, and they get it prepared in the afternoon while the sun's still out, and then they'll go and lay insulated blankets over the top of it. And the next morning, come back, pick the insulated blankets up so that they can pave it the next day. But that goes back to a cost, and that goes back, if I go back one slide, to ultimately only the person paying the bill can answer that question. Is it worth it? Do you want us? You need it paved that bad? Well, we can do these. There are things that we can do so that we can continue to work, but it's going to cost you money. So with that, I'm a little bit ahead. I got through that in about 50 minutes instead of the full hour. But if there are any questions, Mike, I would hope that we had like hundreds of questions while that was going on. I would be happy to answer those at this time.
Tom, we've got a handful of questions, so I'm going to go through them. But before you do that, I'm going to add two comments just to ask you to elaborate on them. As always, you're providing practical and useful tips that are applicable in the real world for our industry. So thank you. Can you elaborate for just a minute? What does that partnership look like between the paving contractor and the inspector to be successful in these types of environments?
There has to be, like exactly what you just said, Mike, a partnership. It can't be an adversarial type relationship. It has to be something that the inspector and testers on the owner side have some knowledge and understanding of what the contractor is doing, not only what they're contractually required to do, but what they are trying to do to meet the specification in the contract. So they have to have that understanding. And there also has to be an understanding from the inspector and testers or the owner's side that they will work with the contractor and the contractor will work with the owner to give them the best possible product that's going to meet their initial life cycle analysis.
And also, can you elaborate, just tell the short story how you've seen the success of cold weather paving, paving at high altitude, 11,000 feet and above at the Eisenhower Memorial Tunnel, in the middle of winter when there's been some emergency operations and how that can be done successfully.
Yeah, it's a matter of planning and timing. I showed in one of my earliest slides there where they had taken the paver out and heated the paver up, had the screed heated, and were running down the road with just a heated screed to try and get everything thawed out enough that they could come in and pave, even in a very cold situation. You saw in that slide, there was snow on the ground. They went out with the motor grader, they pushed the snow off, and then they came back with the paver and they were heating up what they could heat up, and they were doing it in very short segments. They were probably doing a couple 100 feet at a time, and then they would get the material down, then they would do the next couple 100 feet and do the next couple 100 feet, so it didn't give it a chance to refreeze or get cold again. Also, the other thing is that by planning, even on a cold day or a cold situation, you talked about at 10,000, 11,000 feet here, where if the sun's out, we have seen, Mike, you know as well as I do, at 10,000 feet, 11,000 feet, the sun's out, snow melts. It could be 10 degrees out up in the high country. We had the very first ski area in the country open up this last weekend. Anybody that was watching happened to watch the Bronco Cowboys game, that the CBS guys showed footage from Arapahoe Basin, which is at about 10,000 feet, opened up. They are skiing. The snow is up there. So, but the road that Loveland Pass, they're still doing work on Loveland Pass to this day. And even though they got skiing going on.
Well, I'm gonna go through. We've got a handful of questions, and we're not going to be able to get to all of them, so I'm going to give them to you rapid fire, Tom. And if you can give us a short answer, we'll get through as many as we can here in the last 5 minutes. While we do that, if you can advance to our last slide, which is the certificate of completion. So go ahead and screenshot that if you're needing to take your PDH credits, or like I said, this video will also be posted on YouTube. In the meantime, couple comments, questions, Tom. Somebody was asking about the influence of wind and its impact on ambient air temperature. You addressed that in the Pave Cool and some of those tools that are available that will account for wind.
Yeah, they do account for wind. Wind and ambient temperature and wind are, the wind is a problem because it will, if the contractor is not paying attention to it on a cold, windy day, closing the voids, the cold air blowing through that mat is going to chill it very quickly, and they're going to lose the ability to get it compacted.
In your experience, what is the most common mistake an engineer would make regarding paving in cold weather? This is an engineer's perspective.
Um, Thinking that it is they can go, well, it's a nice, I mean, we hear it all the time. It's a bright, sunny day. Why are you not paving? Not understanding the challenges that the paving contractor has to get the material down, and assuming that just because the sun's out, you can pave and make it very successful without making some concessions.
Does the material transfer unit solve the temperature segregation issue?
It does not solve it, but it will eliminate probably 98% of it.
There's a lengthy question in here about increasing thicker base lifts in order to increase the time. Just quickly reiterate how you address that about design sections and thicknesses.
Yeah, the design section is what the design section is. If they're paving late in the season and you've got a mat that has to go down and it's 6 inches, doing 3-inch lifts is going to be much more advantageous than doing 3 2s or 4 and a 2. So the thicker the mat, and I showed you that in that one illustration where if you had 3 inches, it went from like 20 minutes to like 40 minutes to get the material compacted by just that extra inch of material because it will hold so much more heat.
Here's a question that comes out of Oregon. So they have in the Cascade Mountain Range, they do have issues with cold weather. And the question is in pavement design reports, what's your thoughts about adding sections in there specifically about cold weather paving and providing best practices?
I think that's an ideal situation, but you have to be careful. If you're putting something in a publication that people will read it as a specification or it's the Bible of what you've got to do, it's got to be written as a guideline as opposed to specification or a hard and fast rule. Because everything's going to change a little bit. If you're paving here at 10,000 feet or you're paving down in the city here at 5,000 feet, completely different, same scenario.
Here's a question out of Washington State. What is your opinion on pneumatic tire rollers in the compaction train? Some states like Washington require it for cold weather paving, but most contractors don't like it.
My opinion is that the pneumatic tire roller is the most important roller in the paving train. If you have now, with that said, if it's a polymer modified asphalt, that becomes a real problem. The rubber from the tires and the polymers tend to stick to each other. It's important that if you have to understand what binder you're using, but the pneumatic tire roller will get the material kneaded together faster and you'll get that density in there, and it'll also generates a little bit of heat through the friction of the tires being run up and down the road. So my opinion is the rubber tire roller should, be always here in Colorado. The CDOT specification is it says that every project must have a rubber tire roller on the project for the compaction process. It's written into the specification. However, on our interstate and state highways, they do a lot of polymers. So it gets waived because they can't put it on. There is a contractor here in Colorado that has figured out a release agent. They build their own release agent and they use rubber tire on even polymers and they don't have any problems. My opinion, rubber is the best.
Excluding the discussion of cost, are there any downsides to using a WMA additive?
None.
Short and sweet. Are there any precautions to take in very strong cold weather? Should blankets be placed on the roller drums? You talked about blankets on the subgrade. What about protecting temperatures on equipment?
I don't know how you would do that. Put a blanket on a roller drum. The roller drum, when they start, it's going to be cold. So, and that's, the takeoff joint is always one of the worst places on a mat anyway. So then you're putting a cold drum. So can they heat the drum up? Yeah, they can use you could use like a weed heater or weed burner. Heat the drum up before they get on that mat. That would be an ideal situation. There are other things now I've actually seen where they will mount like an infrared across the drum to help keep the drum hot. I've only seen that, I think, once. I've seen that where they used an infrared heater right on the drum to keep the drums hot. But other than that, Mike, I don't know any way that you can keep those heated.
Well, Tom, I want to thank you for your time and expertise. 45 years in the industry doing this.
47, thanks.
47 is invaluable. And it clearly shows your passion for teaching and training. So if anybody has any additional questions, you can contact Tom directly at the Colorado Asphalt Pavement Association. That contact information is available on the CAPA website. You can
back
Google
up on
that.
the screen.
And here it is on the screen. And we want to thank you for joining us here at the APA, promoting quality, construction, and long life asphalt pavements across the country. Thank you all for joining us.
Thank you, Mike. Again, I appreciate the time.